the definition of what this right here means, limit. All right, a limit as x approaches 2 of f of x equals, and this graph right here is f of x. Okay, so one thing I want to point out is this right here looks really weird, right? We're learning a new language, and so at first it could seem very challenging in terms of exactly figuring out what it means. But all this is saying is, what is our y value? So the y value is going to be right here. What is our y value when, well, it's right here, x approaches 2. So this limit just means approaches. So as what happens to our y value as x approaches 2, and that's all the LIM stands for. It just means what is our x value? Well, look at this graph. All right, when the x value is 2, well, what does our y value become? And the question is, well, how many directions can you go to that y value there, right? When x is 2, we can approach it from the left. And as we approach it from the left, well, our y value gets closer and closer to 5, right? And as we approach it from the right, again, as we approach it from the right, our y value gets closer to 5. Okay, so when we're asking what is our y value when x approaches 2, we are essentially asking two things. We're asking what does it approach from the left, and what does it approach from the right? And if you look here down below, right here, you'll see this exponent with the negative. That negative in this kind of definition means from the left. So that just means, what does the x value approach from the left? Well, remember, we did it from the left and it was 5. And here, the plus sign here, well, the plus sign means what are we approaching it from the right? Okay, and that's exactly what these two definitions mean. And if we do that and it gives you that same y value, then it means, well, then that means that it's approaching 5, right? Because this approaches 5, this approaches 5. As long as from the left and the right, they're both the same, that means the overall limit, the overall y value that we approach is 5. And the reason why we like this is because, well, if you look at the graph, I kind of already drew a bunch on it, but you'll notice there's a hole here. Okay, there was a hole there, which means it doesn't exist, right? It's undefined at that point, but using limits, we can at least understand, right, what the y value is approaching. Okay, so let's go to this example problem here. Now, I want to show you something real cool in this example problem, and I hope this will finally make sense, all right? And kind of what I talked to you before, I told you that if you want to find the limit, right, we want to find the limit as x approaches 1 of f of x, okay? Essentially, again, what we're just trying to do is I'm basically just telling you, right, as x approaches 1, well, of this graph, what is my y value? And in order for us to do that, I told you that we have to consider the left and the right side, right? As we approach it from the left and as we approach it from the right. So this is what we want to answer. That's the question that's right here. In order to do that, we first have to consider, all right, all right, the limit as x approaches 1 from the left. Okay, as x approaches 1 from the left, what is my y value? So I go to the left of my function and I'll just kind of draw it in so you can see it. I want to get closer and closer to 1. And as I do that, I'm essentially getting closer to this y value, which is 1. Okay. So my answer is 1, okay? Now we have to take into consideration from the right side. So I'll put then that little plus means from the right. What, as x approaches 1 from the right, well, what on earth is my y value? So I'll start all the way from the right and I'll approach closer and closer to 1. Well, as I get really close to 1, here we go. My function approaches the y value 2. And I'll write 2 here, okay? So I hope that this example problem will really illustrate why we have to consider the left and the right side. Well, because if you look, from the left we approached 1, and from the right we approached 2. You see how that's inconsistent. We don't approach the same y value. Therefore, we can conclude, okay, that the limit as x approaches 1, well, does not exist. Here, I'll go ahead and write down the answers we had, which was 1, as 2. Well, here, this one does not exist. Okay. Last but not least, the next thing I want you to look at is I want us to, and that's my puppy walking around, I apologize. I want us to look at this example problem here. This is saying f of 1, okay? F of 1. Basically, I'm saying if this is my x value, what is my y value on the graph? So now I go when x is 1, well, what is my y value? Well, there's a hole here, right? So if there's a hole, that means we're not defined at that point. So we would generally write undefined, but because we have this circled in dot right here, that's letting us know that there is indeed a value for that expression. So that means that when x equals 1, well, then our y value is right here at this dotted circle, which is 2. Okay, so that's 2, right? And this one here is probably a little bit confusing, and we're going to hopefully go through a few example problems here that'll really help us understand these. All right, so let's go to example problem number 2. Okay, again, I'm going to highlight this problem here because it's asking the limit as x approaches 1. What is my y value? Well, I mean, again, I can't stress enough. When it tells you as x approaches 1, what is your y? We have to think about the left and the right. So we look at this one here. This is as we approach it from the left. Well, as we approach it from the left, I'm getting closer and closer to right here, which is, all right, looks to be about, I don't know, negative 1.25. Okay. Now we have to consider, right? This is asking us as x approaches 1 from the right, right? And so we start at the right and we go and we follow it. So you see how I'm following it. And as you can see, well, I'm getting extremely close to, it looks to be about 1. All right, so I'll go ahead and write 1. Well, because from the left side, we approach negative 1.25, and from the right side, we approach 1. Two completely different y values. We can conclude that this does not exist, right? It doesn't exist. It's a contradiction. We are approaching two different y values. Last but not least, the problem is asking us for f of 1. Well, when x is 1, you'll notice the holes means they're undefined there, so we ignore them. Well, we do indeed have a solid dot there, and the y value there is 0. The y value is 0 there because it's on the x-axis, so that's 0. All right, let's go ahead and look at another example. We'll kind of go through these even quicker just so that we can kind of understand these. Again, this problem is asking us as x approaches 1. Well, from the left, what does it approach it? And from the right, well, from the left, as I get closer and closer to 1, well, my y value is 1. So I'll put 1. And as we approach it from the right, okay, and as we approach it from the right, like I mentioned, as we approach it from the right, well, what is my y value? Well, as I approach it from the right, well, it's also approaching the y value 1. All right, therefore, we can conclude, because this example here, right, from the left we approach 1, and from the right we also approach 1. Therefore, as the limit as x approaches 1 of f of x, our y value is indeed 1. It does exist because it approaches it from the left and from the right. Last but not least, maybe this will help clear up some things. All right, now we're trying to find f of 1. Well, at f of 1, we have this open circle. It's undefined there, and we don't have like another solid circle like that to say, okay, well, at 1 it's 2. We don't have that in this graph. Therefore, this is a scenario where it is undefined, right? Where it does not exist. It has a hole, which means it's undefined there. So we can write undefined. All right. Let's go look at this last example problem. So you can just, hopefully by now, this will really become routine for you. And as you can see, as x approaches 1 from the left, let's do that one first. Okay, as x approaches 1 from the left, we just did that earlier. Our y value is 1. So I'll go ahead and write 1. And the same thing as x approaches 1 from the right. Well, my y value is 1 again. Therefore, the limit as x approaches 1 overall is 1. Now it's saying, well, what is f of 1? Well, again, it's undefined here, but look, we do have this solid dot here. So that means that at f of 1, our y value is indeed negative 2. Okay. So I could say -2, all right? And hopefully that really helps you to understand how to do these problems. I hope you feel really confident now of what this means. Again, we just want to find out what it approaches from the left and the right, and we kind of take that into consideration to determine the overall limit here, all right? So in the next video, I'll go ahead and go over what I think was 2 of the more challenging problems that was on the homework, and then we'll kind of make sense of that, all right? So take it easy.